So for our project, we decided to do the recycling of thermoplastics. Before looking into the different types of thermoplastics, it's best to look into the recycling operations in general. First off, products are collected for processing, and then they are sorted into their different material types, which afterwards they are broken down and cleaned. After this process is complete, the recycled material is then fabricated into new products and then shipped out. Looking at the data in the chart we have right here, you can see that over time, the actual waste of the amount of plastics has been gradually increasing, with a massive increase over the early 2000s. The majority of this excess waste, instead of actually being recycled, is just being dumped in landfills, whenever in turn we could be using it as thermoplastics and reusing them. There are 5 different types of thermoplastics, those being HDPE, LDPE, PVC, PET, and polypropylene. All these thermoplastics have covalent bonds, which allows them to actually be reused indefinitely because of their weaker structure. So that way, whenever they're heated, they're soft enough to actually be molded and cooled into a more rigid structure. The only problem is they can only be recycled a certain amount of times, as there are also chemical additives put into it, which are meant to strengthen the bonds, which in turn neglects the entire purpose of it. Looking at the mechanical properties of the high-density polyethylene, there's a greater improvement in the composite strength due to a mixture of components with compatible types of their size and the particle shapes. The only problem is that it ends up having an inconsistent melting flow rate, and the only way it can actually be stabilized is through a mixture of phosphite and phenolic. Only problem with this is it is actually not economically suitable. But the good thing about it is through this, the enhancements allow increased adhesion, biodegradability, biocompatibility, and non-toxicity to the environment.
So low-density polyethylene is a common thermoplastic used in plastic film, grocery bags, sandwich bags, and many more products. This table shows the material properties of unmodified and modified low-density polyethylene. So many different types of modifications were tested on virgin and waste LDPE. Some of these modifications, for example, include adding a polypropylene, which actually increased the tensile strength and the tensile modulus. The goal of this testing was to see if these modifications could improve the mechanical properties. In doing so, this could allow for recycled LDPE to be used in different ways. The recycling processes we are going to discuss include pyrolysis, methanolysis, and gasification. One of the most commonly used processes is pyrolysis, which is used to convert plastic waste into energy. It works by degrading the plastic waste at different temperatures without oxygen in order to produce liquid oil. This graphic shows the process of pyrolysis. First, the waste plastic is put into a Napper extrusion machine, which then leads into the pyrolysis reactor, where a catalyst is mixed in with the plastic waste and is heated at a specific temperature. Catalysts have different effects on the efficiency of this process. The most commonly used catalysts are ZSM-5, zeolite, MCM-41. The condenser then condenses the fuel gases out of the product, and the remaining product goes through the mixed oil tank, where it is then separated into layers in the fractionating tower. The reason that this occurs is because of the different densities of the final products. This graphic depicts the process for low-energy methanolysis of post-consumer PET plastic waste. Methanolysis is a process where PET plastic waste is heated and treated with methanol. This causes PET to depolymerize into its component monomers, which are DMT and EG, and then these monomers are then used to produce new plastics. Gasification is a process used to convert plastic waste into fuel. This process occurs by reacting the plastic waste with steam, oxygen, or air at high temperatures in order to produce synthesis gas. As shown in the graphic, there are 4 processes involved in gasification. These are drying, pyrolysis, combustion, and reduction. Overall, All of these methods mentioned are essential in order to reduce the amount of plastic waste constantly being produced.